Hello and welcome to this presentation on CIM and asset management. I'm Neil Meredith, I'm the lead solution architect. I work in the IT department for Scottish and Southern Electricity Networks, usually abbreviated to SSEN. So what I'm going to cover in this session, just a little bit on the business background in terms of who we are, and a reminder about why we are pursuing CIM as a core part of our strategy. I'm then going to explain our systems architecture and our integration strategy, particularly looking at how that applies to asset management and how we're using CIM there. I'm also going to talk about something we're calling the common network model, and how we are using CIM to build up that common network model, and also give you a view of how that applies to asset management. And then just briefly at the end on lessons learned, and it's something I actually learned from the CIM conference around about this time last year. Something we followed up on, it'd be worth just give you an update on. So into business background. So Scottish and Southern Electricity Networks. We have a distribution and a transmission operation. So our distribution operations we have within the south of England, actually where I live, see us there. But we also operate the distribution network in the north of Scotland. And we also have a transmission business. So we're the owner of the transmission network, again, within the north of Scotland. So why have we adopted CIM? We've adopted it for a while, actually. Probably we made a decision about using CIM probably about 4 years ago. I would say it's in the last 2 years we've actually been using it in earnest. And there's a number of factors of driving us. Particularly what I'm going to talk about today is around IT transformation here and how we're using it to integrate our systems together. But I'll also make some reference to the common network model, which is part of our digital strategy, and enables us to build out capabilities onto our analytics platform. There are other drivers for adopting CIM, which I'm not going to cover really in much detail here. In terms of the wide industry in the UK, increasing focus within the Energy Networks Association, and also we see it as a key part of our transition to becoming a distribution system operator. So I'm going to talk about our architecture and our integration strategy. So starting with our integration strategy, we decided way back that we were going to use an integration layer to actually integrate our business applications together. Now we're using a set of products from Oracle under the Oracle Fusion banner to do this. So our default is to use that integration layer to plug our systems together. Unless there's good reason for not doing so, and there are some cases where we wouldn't use that. Some of our products do have out-of-the-box capabilities to integrate together, and some of those are CIM-enabled. So there's no need for us in those cases usually to have to put anything else in the middle of them. So having established we need an integration layer, our next decision was to say yes, we want a common messaging model. That is a long-established integration best practice, and it helps decoupling the applications. It starts building up a common exchange format for messages to be exchanged between systems. So the next decision then, well, okay, what is that common messaging model? And we landed on the common information model, probably directed by both business and IT. So I think from a business point of view, I think this was becoming familiar and was particularly pertinent, we thought, in the context of moving to become a DSO. But from an IT point of view, it actually gave us a really good head start. There's a model there, it's a standard, we can use it and adopt it for ourselves. So system architecture. So the core to this is our working asset management system. IBM Maximo, together with our GIS system, which is based on GE's Small Electric Office. There's quite a bit of communication between these two systems required. Largely, GIS is around the linear assets and Maximo around the non-linear assets, but both systems need a full view of the assets to carry out their operations. As well as IBM Maximo as the core asset management project there, we also use Maximo Anywhere, which is a mobile data collection app provided as part of Maximo. But we have other apps we've developed or developed with third parties that are also used in terms of gathering data for inspections and maintenance, for example. We have a product called CIM, and also something we've been using in transmission primarily, but recently started using it within distribution. And this is from a company called Cyberhawk. And this one is concerned with actually using drones to scan our overhead lines, produce inspections and maintenance data that we can then process within our asset management system. So those are the kind of core ones around asset management. We use something again from a third party from EA Technologies Limited called Condition-Based Risk Management, or CBRM. That's just being re-platformed. But essentially, we can send it asset information, run a number of models within here, and it will calculate condition and health indices of our assets. In terms of systems that actually need to be able to raise work orders, we have a connection system, which are over the next couple of years moving across to an Oracle Cloud. But where we do connections work, we want to raise a request to carry out work associated with that connection and send it through to Maximo. And our outage management system is based on GE Power, or will be based on GE Power on Advantage. And again, for any remedial fault work we may need to carry out, that wants to raise a work order within Maximo as well. And the final one to mention is something called our analytics platform, which we built out on Microsoft Azure. That gives us a number of capabilities in terms of reporting against our data, running analytical models, artificial intelligence, machine learning, and also gives us a means to start exposing that data outwards to the rest of the industry. Now, some of these systems are CIM compatible to some extent. So our GE products I should have a CIM over here as well for Power on Advantage. These are both able to communicate using CIM. CIM, our vendor there, is going to be adopting CIM, and we're expecting Cyberhawk to also be adopting CIM as well for their messages. CBRM, that's recently gone live now with a CIM model there. And our analytics platform, whilst the messages across are not necessarily based on CIM, the underlying model that this is used in terms of a data model is based on CIM. I'll talk about that later. CIM in the context of asset management. So quite a busy diagram. I don't expect you to be able to read all the lines on this. But the model we're going to in terms of our target architecture is that Maximo becomes the source of all our asset data. And we have say asset data as indeed includes location data and work order data as well. And we have a number of systems that will be consuming that data. So some of these will be the mobile applications such as CIM and Cyberhawk. Some will be an exchange of asset information, for example, with Electric Office. And some will be like CBRM and our analytics platform, where we can send asset data to, carry out those models there and send any results back. So the idea being that we try to get to a single asset message out of Maximo. Our integration layer can then take care of that. Initially, it transforms it into CIM and then passes it on to whichever systems need it. Some of those systems, it will send it straight across in CIM format. Others, it will need to convert it into a more proprietary data format. And similarly on the way back, so if we take the example of service requests, so these are requests to create some work orders. They could come from our OMS system or our connection system. We don't expect this connection system to be sending us CIM messages across. However, the OMS may well do. But everything in the core of the transformation piece here is all about using that common messaging model around CIM. So the status of these, the ones we've built now, sending asset and location data out to the CBRM, and it sends us health and criticality indices back. And we have an exchange of asset information with our GIS system, the Electric Office. These others are to follow later in our roadmap. So our SIM development process, and we've used this a lot for within asset management. And one of the key things has been the data mapping files. So we need to understand what data is being provided by the source system and what it needs to be when it gets to the target. So I'll just go back to the previous slide. You'll see, if it would show it. For example, we have a source data with Maximo and we have the target data with CBRM. The mapping files give us a route through to understand, well, okay, we take some attributes from Maximo, what do we need to convert it into to get it to the target system? Once we understand that, we can then map in where SIM fits into this. So what is the SIM equivalent of a Maximo attribute? We then use the Sparks tool to make any amendments we might need to do to the underlying SIM model. So that's managed as a UML model, Unified Modeling Language, and we can update that as we need to using the Sparks tool. We can then export it out into something called an XMI file. So this is a means of exchanging model information between tools. So an export out of there, and then we import it to SIM tool. Some of you may have come across. So this is an open source tool, freely available. And what it allows us to do is to create SIM profiles. So, typically we will create a profile for an asset, and that represents, information we're going to exchange. We can then use those profiles to create the actual message exchange schema. So sometimes these are just XSDs, but could equally be RDFS, the Resource Description Framework. We can then use those schemas within our applications and middleware, so within our integration layer. So it's just an example of data mapping. So here we have some Maximo assets, some Maximo attributes. So the asset type, for example. Initially, we would map it onto what the target system might call this. So in this case, this target system was calling it asset group. That was its view of what an asset type was. But we can find the SIM equivalent here, which is asset on the asset entity and has an attributed type. Most of these map across to existing ones. Sometimes we do find new elements that we need to add. So this operational restriction was quite an important one for us. There was no SIM equivalent. So we amend our SIM UML model to add that in. The way our asset management system Maximo works, it has something called specification tables, both for assets and locations and work orders. This means the business can pretty much define anything they need to in terms of data. So it makes it very flexible, but essentially what we end up with is a set of name value pairs, and there's quite a lot of these. So in this case, they have something called high risk neighbors. Now that could be, it could be a number, it could be a Boolean, it could be a text. Usually these do not map into anything with a SIM equivalent. Fortunately, SIM does have a similar construct in terms of name value pairs using something called user attribute. That enables us to get these attributes to flow through into SIM. Just a note at the bottom here. Regardless of whether SIM's used or not, one of the most difficult things in doing these integrations is data mapping. It's trying to understand what information am I trying to get from this system to that system, and how do these elements match together. That's a challenge, whether you use a SIM or not. So what have we created so far within asset management? So these are the profiles we have. So the main ones, these are the ones that we use to send messages from the integration layer. Our asset, location, and the work order. So the work order could be the need to carry out an inspection or carry out a piece of maintenance. And so we create profiles for those. So those are the outbound ones. So the messages come from Maximo in the Maximo proprietary data format. The integration layer uses those profiles to convert them into the CIM message. It can also send back a response. I'll come on to that one. So things coming into Maximo. So from our CBRM system, if our health and criticality index results come back, processed in CIM format and converted into Maximo messages. Similarly, we can get responses back. So having sent out these work orders, so typically out to our mobile apps, we want the results of those work orders coming back. So what was the result of the app inspection? What was the result of the maintenance? So that data flows back in, converted into CIM and sent on to Maximo. And the service requests are inbound, and this is where other systems want Maximo to record a work order. So it could be somebody's found a fault while they're doing an inspection or maintenance. It could be a remedial fault following an outage, or it could be to create a new connection on the network. So again, don't expect you to read this, but just give you a flavour of what's in the information we're having to use for CIM. So this is a part of the UML model shown in the Sparks tool. So we have our asset set of classes here, various diagrams that show how those classes relate together, and then details of the individual classes. What we've done in terms of where we are making modifications to the classes within the UML model, is actually just keep those into a separate package here. So these are just called modified CIM assets. And that just enables us to keep a track of the fact, well, yes, we have made some changes to these, maybe changing an enumeration or adding a new attribute. The reason for that is as the new versions of CIM come along, we've actually got a record of what we changed. We can then check if we need to make any further amendments to our tailoring. We find these useful. We create these out of the Sparks tool. These are UML class diagrams. Again, you can zoom into the presentation, but for now, just point out asset, obviously the core of this, and we're just showing the relationships between the asset class and all of the other classes and attributes that are used within our asset profile. So that's useful just to understand the makeup of the profile. Quick screenshot from the CIM tool. So having imported the CIM model into the CIM tool, I can then start building up profiles. So if I want to build up the asset profile, I can start selecting the classes and the attributes, the overall CIM model I want to include within my profile. So I can move those across. I can add the attributes I need. I can change the associations I might want between those, and I'll ultimately use that to generate the schema. So the last bit I wanted to talk about was around our common network model. So some background to this. So this is being driven from part of our digital strategy, which is something we launched formally a year ago. And there's two aspects to it really. One is actually digitizing our data, and the other is actually making that data available more openly for our customers and partners in the rest of the industry. And the reason for deciding we needed a common network model was actually we need to bring together the data from our core systems and indeed the external data set into a single integrated view of that data. The challenge with the data is it's mastered in core systems like Maximo, like Electric Office, for example. But each of those has a very different representation of data and the way it's modelled. And if we're going to use that data, whether it's for analytical purposes or making that data available, we do need to make sure it actually joins up into a whole that makes sense and is consistent. So the core of the model is our electrical connectivity model. So that represents our distribution network. That is being built out over the next few years. It's ultimately going to go down to the LV level, and we're hoping eventually right down to the property level. So that's the core of it. Fits very nicely with CIM in terms of how that can be represented. But we need to supplement that with associated data. So information about the assets, their condition, their age, for example, operations, so what operations being carried out on those assets, what faults might we have in place, or historical faults, or outages are in place, or have been in place. You know, what's connected to our network, who's connected, how are they connected, and information about external parties who use our network. This particularly starts becoming the case, these latter two, as we move to becoming a DSO. So that network model itself, we needed a logical data model to represent that. Our options here were, is there something out there we can already use as a data model that represents data about a distribution company and its assets, or would we try and build our own? Now we did consider, can we build a data model based on the UML model that's provided CIM? And yes, we probably could, but I think it would have been a good deal of work. So we made the decision about a year ago to actually purchase something called the IBM data model for energy and utilities, DMU for short. So as well as underpinning the data model, it also gives us a predefined set of data structures and contents. So this also helps us in terms of data governance, data cataloging, how we represent our information in the data warehouse, and therefore can be used by our analytics projects as well. The good thing about this DMU is it itself has been derived from CIM, and you can see the linkages through between the CIM classes and the entities within the DMU. One other feature it has in there as well is you can actually trace from the entities and attributes in the data model back to the Maximo APIs, which is useful when we're looking at mappings and integration. So it is a set of standard models. It's derived from CIM, and key for us was it rationalizes the UML class model into a logical data model. Important distinction to make there. What you get with the underlying CIM is a class model. It's not something you would try and implement as a data model. So CIM, using things like CIM tool to create for profiles for data in transit, if you like, but we're using this DMU to represent the data at rest within our databases. So we use it to represent the logical models, also the physical models for the common network model, and we can use that information then for a number of things. So we can do reporting against it, produce KPIs, we can run analytics, machine learning, artificial intelligence against that data. It gives us a foundation for data management, which is key to the success with most of this, and also enables us to bring that data together in an integrated way, so we can start sharing it with our customers and partners. So how does this work in practice? So obviously the core of asset data within the common network model is coming from our IBM Maximo system. So we'll say it has assets, location, and work recorded in the common network model. And within these kind of domains, if you like, there will be a set of entities within the DMU to represent asset data, location, and work data. But we want to supplement that with other data that's around. So we can take fault and outage information from our outage management system, which is ultimately going to be Power On Advantage. We can take the connectivity model from our GIS system, Electric Office. Over time, we're just going to start supplementing this with scalar data. So from our Pi Historian and our iHost systems that are actually recording events on our network, we can ingest that into the common network model. And we can also start taking in information from our ERP systems. So the costs and volumes associated with our assets and the work we do on those assets, which is important for us in terms of regulatory reporting. So this is just one part of the common network model showing how we're building up that data. Core of it, the connectivity model, but starting to supplement that with information from other systems to give a complete view of the assets. And a number of use cases then where we can start using that for. And one of the ones we're quite focused on going forward over the next few years is making that available as open data out to our customers and partners. So some of the use cases we got underway at the moment. So quite a bit around reporting. So this enables us to report on performance. So how are we doing against our business plan and our regulatory commitments? We're just starting to look at data quality. So we can start running models to assess the quality of our data and where we need to focus. And also from a business performance point of view, is there any unclaimed value? So are we doing work we're not actually claiming for and therefore not getting paid for? The initial set of analytics use cases in this area around predicting faults, moving towards predictive maintenance, looking at how we optimize investment into our assets, and gaining productivity insights around the work we do on our network. And for open data, the key focus will be around flexibility resources. So these are typically distributed energy resources that are connected into our network, providing further information out to them so they can understand the opportunities providing those flexibility resources to us. Just finally, lessons learned. I'll put this slide up at the last CIM conference. One of the things we did talk about there is, using CIM does require a combination of both business and IT expertise. So I'm an IT expert, so I can understand UML models and class diagrams. I can understand message schemas and profiles, integration technologies, data models, how they all work. I don't necessarily understand what the contents of CIM is. So, do I really understand how a transformer works and the elements within the CIM model that make up transformers? Probably not. That's something people in the business team understand in detail. So it does need that combination of knowledge to make this successful, and particularly so when we're doing data mappings into CIM, understanding how we're going to use it, and even flowing through to our common network model. So just to finish up on the last two here, so what we decided to do, this came to me as an idea during the last CIM conference. Wouldn't it be good if we can run joint knowledge share sessions with business and IT? And how we did that, we did a number of these sessions. We're not quite finished with them all, but we took a particular aspect of the network, the physical network. So, for example, here it was around circuit breakers. So one of the business SMEs would talk us through a circuit breaker, what it is, what it does, using pictures as well to illustrate them. So often we see these things when we walk around, but by having somebody from the business explain what some of these parts do, how circuit breakers work, imparted that knowledge from business SMEs into the IT team. And the second part of these sessions were then, okay, so what do circuit breakers look like in the common information model? So again, using one of the class diagrams, focusing on the core classes that represent circuit breakers. So, for example, switches, protected switches, all being part of protection equipment, showing that there are different types of switches, reclosers, sectionizers, and so on. So we could relate back from what the business had shown us in terms of the actual physical network into the abstract view of that, if you like, within CIM. And that helped the business folk, of course, then understand what is CIM telling them in relation to their view of the real physical world. Okay, and that's the close. I hope that was useful.
Thank you so much for watching. I hope you found this video insightful and enjoyable. We post new smart grid related videos every Friday at 12 CET, so please go ahead and subscribe and let colleagues in other departments and peers in other organisations know so that they can benefit too. We welcome your feedback, so if you have any comments or questions, please feel free to post them below. Thanks again and have a great day.